Welcome to Math 119, Chapter 7.1, where we are talking about radian and degree measure. So recall that from geometry, an angle AOB consists of two rays, A1 and A2, with a common vertex O. Now we know that O is the vertex because that is the value or the number or the letter that is sandwiched between the two rays A and B. Now, if we're talking about these positive angles, let's see, we have our initial ray. This is ray 1. And this is, well, let's just say this is ray 2. And your pivot point, your vertex here is at O. Now, ray 1 is called your initial ray. And ray 2 is called your terminal ray. So initial meaning, hey, this is where we are going to start, and your terminal is where you end up. Now, the angle that is between them we'll call theta. Now, theta is going to be positive if we are going in the counterclockwise motion. So as long as we are traveling around in this counterclockwise motion, this angle is going to be positive. Now we can also have a negative angle. So your negative angle, let's again take these two rays. Your initial, this is ray 1, and let's just say this right here is ray 2. We can say this is O here. And again, this is where you're starting. Your initial is ray 1. And your terminal is ray 2, and you have theta that is between them. Now this theta is going to be negative if we are going in the clockwise motion. So we go clockwise here, and we can keep going around and around, so getting a very, very large degree here. But it would be a negative degree. So counterclockwise, we're talking about a positive angle, or clockwise, we're talking about a negative angle. Now, how do these two rays relate to trig? Well, imagine that these are actually part of your unit circle, whereas this initial ray is this very first ray right here that we start on for the unit circle. Let's see if I can get this right here. Your initial ray, there we go. This is your initial ray. Think about that as kind of where your initial ray is. And then wherever you end up stopping, this could be considered your terminal ray. That could be at any point in time on your unit circle. And you could be going this counterclockwise motion or clockwise to make that angle positive or negative. But we're always going to be starting here and ending up somewhere along your unit circle. Let's say that this second one is your terminal ray. Let's say that this is your terminal ray right here. And notice that the angle that is going to be between them is just based on the direction. So you might be seeing these like little loops around, or the one right here. You could have that theta. So as long as it's going to tell you the direction, which it should always tell you the direction, you will end up having either a positive or a negative value. So that being said, let's relate this now to the circle itself. So around the unit circle, right, we just talked about either starting or stopping to have a positive or a negative angle. Now the unit circle has what sort of radius? Well, you can see right under where I put the word terminal, maybe I can scoot it over. Nope, I'm just perhaps just going to erase that whole value right there. Right under where it says terminal, we have the value of 1. Well, what is that 1 talking about? Well, a radius is anywhere from the center, right, from the origin or our vertex we had talked about before previously, just talking about geometry being 0 or O, right? In our case, we're going to be pivoting around this origin. So at each point in time, we're going to be going from the origin. Now, every time that your ray touches the outer wall of your circle, that is going to be talking about your radius. Your radius has the same measure all the way around because that ray is going to be the same value. Now, notice that what value that is, we said 1, and that relates to all of these values here on the coordinate plane. We're taking a circle with a radius of 1 and putting it right onto a coordinate plane. So let's talk about geometry a little bit more. What is it called, the distance around the circle? So we just talked about radius here. What is it called if I travel this whole distance here around the circle? Well, this is called the circumference. The circumference is the distance around the circle. Now, in case it's been a minute since we've seen some geometry, right? The distance around the circle, your circumference, is equal to C is equal to 2 pi r. Where's that 2 pi coming from? Well, 2 pi is one full rotation around the unit circle. We always start at 0. And when we travel this whole distance here, when we end back, instead of ending at 0, we end at 2 pi. Now, the r is talking about your radius, which we said your radius is equal to, in our case, what number? Well, your radius is equal to 1. So on the unit circle, when it talks about circumference, we're just talking about 2 pi. Again, this is because your radius is equal to 1. Now, in case they ask you in future the degree of the angle, we do have this quick little formula where this is called your theta right here. This is the degree of the angle. S is called, let's see, I'll use that color. S is arc length. So arc length, like these being your arc over here, and R being your radius. I will not be asking you what the degree of the angle is. Typically, at least not in this sort of capacity. We will be talking about it when it relates to your inverse trig down the road. Now, we are going to be talking about the equation of a circle. So equations of a circle is x squared plus y squared is equal to r squared, where x and y are just your coordinates, right? So x and y are just your x and y values seen up here, right? Just a series of points around your data or around your circle. Whereas r, right? Well, what does r stand for? R stands for 1, and that 1 is not going to change on the unit circle, right? We can have a radius of a regular circle being more than r, but for our case, when it comes to the unit circle, we can actually go ahead and rewrite this equation to say x squared plus y squared is equal to 1 squared, which 1 squared is just itself 1. So you're going to be seeing a lot of this formula down the road, especially when we apply it to trig identities, but I definitely want to show you it now. Now let's talk about radian measure here for a moment. So for a circle of a radius 1, the length of the arc is an angle measure in what we are going to be learning today as radians. So the circumference of a circle with a radius of 1 is 2 pi, right? We just talked about that being the circumference of a circle, starting with that radians, right? However, 2 pi is related to what in degrees? So we said, okay, well, if we start at 0 and we travel around your unit circle, that's going to take us to 2 pi. So what if it was in degrees? Well, to travel around the circle, right? If this is now 0 degrees, we've now traveled all the way back to 360 degrees, right? Turning in a full circle back to center is 360 degrees. Now let's talk about um, your half of your circumference. So if this was a full rotation, so if that was one full rotation around your unit circle, so you started at 0, you went all the way around to 360 or 2 pi. So let's talk about, okay, well, if we need to start to convert, right, it might be a little bit easier to figure out, well, okay, well, what is 1 radian, right? Because this is 2 pi radians. Let's figure out, well, what is 1 pi radian, right? Well, 2 pi, or how do we go from um, 2 pi all the way down to 1 pi, right? Well, that's just half your graph, right? If this is the whole thing, half of it should be over here at pi radians. So half your circumference is just pi or 1 pi radians, which translates to what as far as degrees goes? Well, half of 360 is 180 degrees. So that just means 1 pi radian is equal to 180 degrees. Now we're going to use that logic to convert from degrees and radians and vice versa. So therefore, to convert from degrees to radians, right, if we want to go from the degree all the way to radians, right, that means that our degrees want to cancel, right? So if we have some degree and we want degrees to cancel, we're going to put degrees below, right? Because in science and in math, if we've learned, right, in order for something to cancel, it must be above as it is below. So we're going to be using the idea of 1 pi radian divided by your 180 degrees. So we'll multiply when we go from degrees to radians, we'll multiply by not 360 and 2 pi, but by 1 pi radian over 180 degrees. That way it allows us for your degrees to cancel. And if we wanted to go from the reverse, from radians to degrees, what would we then multiply by? Well, if we want your radians to cancel, and it's not the pi that will cancel, sometimes we can still find just a radian, right? 1 radian, 2 radian, 3 radian, 4 radian, right? We can still find that radian, but notice how I didn't say pi, right? Pi is an actual number. So it's not, it's the radian that I'm writing here that is the unit. So if I want the unit radian to cancel, I then have to have my radians down below. You could write radian, you could write rad, meaning that we're going to take 1 pi radian on the bottom and 180 degrees on top. That'll allow us to cancel the radians. And this pi will remain because pi, as we know, is 3.14 something, 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 right? It'll just keep going. It's irrational. That's why we use the term, the symbol for pi. So to go from radians to degrees, we'll multiply by 180 degrees divided by 1 pi radian, or 1 pi radian. Now, sometimes the context of these will not always give you a unit. So if they do not give you a unit, then the angle should be measured in radians. So assume radians. That is unless we use a triangle. So we can still use radians on a triangle. That's not exactly what I'm saying. But if we just are given a value on some sort of triangle, right? This could be, let's say, 50, right? Well, we still could have 50 radians, right? However, right, we could also have 50 degrees. So if it's found on a triangle without any sort of context, we're going to assume it's degrees. Whereas if we're just talking about just a value, so let's just say right here, if I was talking about conversion, right? If it just gave us 1, we want to assume that this should be in radians. There's no triangle. We'll assume it is radians. So now let's talk about converting between degrees and radians for example 1. So see if you can pause the video here and try some of these values on your own. Well, we have right here pi over 3. Again, pi over 3, it doesn't say it, but this is a radian measure, right? We said even then, like assume it's radians, right? So if we want to go to degrees, right, we have pi over 3 radian times, and how do I get my radians to cancel? Well, I need my radians to cancel if I have a radian down below, meaning that my radian and radian can cancel. So I have 1 pi radians down below and 180 degrees above. Now, what's nice about this particular radian is that your pi will end up canceling. That is not always the case. So we're left with 180 degrees over 3. So 180 over 3 is 60 degrees. Let's try it again with B. We have 270 degrees. And again, you have your degree symbol. So if I want degrees to cancel, I need degrees to be down below and radians to be above, meaning that I have 180 down below and 1 pi radians above. So if I have 270 times pi radians over 180, right? Well, my zeros are going to cancel, right? They also have a 9 in common. So I have 3 pi over 2 radians. Let's do it one more time with 1 radian. So we'll find an exact solution and then an approximated solution. So if we have 1 radian, right, I need my radian down below because it's not the pi that cancels, right? We get lucky sometimes if the pi cancels, but it's the unit that cancels. So we're looking for pi radians down below and 180 above. So your radians can cancel and we'll get 180 degrees over pi. So this is the exact solution. So let's go ahead and figure out its approximated degrees. So we'll push this into your calculator. So we have 180 divided by, let's see, do I have my function? Where's my pi button? There we go. So it's about 57.3 degrees. So on my unit circle, right, if this is a 90-degree angle and this is 0, our angle is about 53 degrees. So this is 1 radian, or about 57.3 degrees. I may have been saying 53 degrees, 57.3 degrees. Now let's get a little bit more conversion. And back on C before I trail, right? If we were to do another example, let's say we did 2 radian, right? Let's do that one, where again, we're still going to get our radian to cancel. So again, this cancels. And now we're left with, okay, well, 2 times 180 degrees, right? So 2 times 180 over pi. So 2 times 180, so 360. Where are we? 2 times 180, 360, divided by our pi. Where did our pi go? Right over here. So 2 radians is 114.6 degrees. So notice that some of those will come out a little bit differently, right? And that should make sense because if 1 radian is about 57-ish, right? And then we've taken another 57-ish, right? It would put us somewhere over here. So this being, let's say, just under here, this would be 2 radians, or about 114.6. I think that was our value here, 114.6. degrees. And again, that's 180 here. That's 0. This is 90 degrees and so forth. So now let's get just a little bit more practice with example 2, trying to convert from from degrees to radians, and then putting those on your unit circle. So if we have 0 degrees and we're trying to convert into radians, right? We have pi radians above and 180 degrees down below. My degrees will cancel and I multiply by a 0, so now I have 0 radians. Now 0 radians located on my unit circle, if I were to label it, would be right here, 0 radians or 0 degrees. Now this has the measure, this has the coordinate of 1, 0, an x value of 1 and a y value of 0, right? Relating it to your coordinate plane and your unit circle. If we did 90 degrees, pi radians over 180 degrees, your degrees will cancel. You're left with 90 pi radians over 180 degrees, or not degrees, so sorry. That'll leave you with pi over 2 radians. So where would we label pi over 2? Well, this used to be 90 degrees, so therefore this is also a pi over 2 radians. This also has the coordinate of 0, 1. Again, these ones are appearing because these are your radiuses, radii. So let's do it again, 180 degrees. And if you already know what these are, by all means, just go and label them. This is just to kind of show you where these are coming from. This whole thing will cancel and we're left with just pi radians. So 180 degrees used to be here, therefore it is just pi radians. This has the measure, or this has the coordinate, -1, 0. 270, and if you see the pattern, by all means, let's see, pi radian over 180 degrees. These will cancel. And I think we already did this one as well, right? Right here. We said this came out to be 3 pi over 2. So 270 is down here. 270 degrees is now 3 pi over 2. Again, this one has the coordinate 0 and -1. Let's do 360. And I think we already talked about 360 degrees being 2 pi. So down below here, we have 360 degrees or 2 pi. Now notice that here I have labeled both the radians and the degrees as 0, and then once more as 360 degrees and 2 pi. That is what I'm looking for. If I give you a blank unit circle, I need all 4. And that does conclude our chapter 7.1.